Hello everyone. Now we start our next concept, planes in a space. In previous sessions we discussed about the planes in a lines. The two types we discussed, a line equation passing through the point and parallel to the one vector, and line equation passing through the 2 points also we discussed. For that 11.2 exercise total about the lines. Now it will start the planes concept. Planes concept same here also two equations is there. Two equations you have to find. The two equations and lines two equations are important for 5 marks questions. Theorems. So now here you see one theorem or one equation. Equation of a plane in normal form. Equation of a plane in normal form. Normal means here, normal always remember, normal means a perpendicular. Normal form. Plane equation in normal form. For every equation here lines or planes, diagram is very important and it will carry the 1 mark. For a diagram purpose 1 mark is there. So that purpose first I will draw the diagram here. First of all take the rectangular right-handed system, that is nothing but x, y, z axis. Origin is O. Take one plane in a space. Actually we draw here plane on the board, but it is not on the board, it is outside the board. If you assume like this is the one plane. If you are taking this is a plane, actually plane is here. We can't draw the diagram outside the board, so that's why we are just here placing. This is outside. This line also one is perpendicular outside. If you are taking room corners, that is XYZ axis. Perfect example for the XYZ axis is if you are taking room corners, that outside of the corner. This is in a space, plane in space. So this is outside. If we are taking here, this is the outside of the plane. From origin you have to draw the perpendicular to the plane. For example, here plane is there. From origin you have to draw the line. Here plane is there. From origin you have to draw a perpendicular line. So we can't draw the direct. So that's why we are placing on this board. This is the plane and perpendicular line we are showing like this. A line perpendicular to the plane. ON bar is a perpendicular. Normal, otherwise normal. ON bar is a normal to the plane. And PBA any point in a plane. Now join the OP and NP. The point P I am taking as a X, Y, Z. That is a common point. Arbitrary point will call X, Y, Z. OP bar equal to R bar. The distance from origin to the plane. Or length of the ON bar. Is D. This is the diagram here. So this diagram representation is very important. This diagram representing words. So that only you can see here. Consider a plane whose perpendicular distance from origin is D. Consider a plane outside. From origin to the plane distance is D. D and D compulsory not equal to 0. If ON bar is a normal from origin to the plane. ON bar is a normal. Normal means perpendicular. Normal means perpendicular to the plane. Perpendicular to the plane from origin. Actual how it is there means this is origin. This is ON bar. This is ON bar. If we are taking here, this is the perpendicular to ON bar, normal to the ON bar. You have to imagine this diagram in 3D. Next, and n cap is the unit vector. N cap is the unit vector of ON bar. N cap is the unit vector of ON bar. Then ON bar vector is distance d. N cap is a unit vector. Distance d is there, n cap is a unit vector. The total vector will become d into n cap. In vector algebra also we discussed. Find out the unit magnitude 7. 7 means first of all unit vector multiply with 7. Here distance is d, n cap is a unit vector. So ON bar equal to here, ON bar equal to d n cap. ON bar equal to d n cap. Just you can write in your own words this total. Diagram representation you have to make here. Next what we took, P be a any point. Let P be a any point on the plane with the position vector r bar. Position vector r bar. One point we are taking, that is OP bar equal to r bar. OP bar equal to r bar. Now continuation here. Now continuation you have to make here. By diagram NP bar is perpendicular to NP bar perpendicular to ON bar. NP bar perpendicular to ON bar. That is, therefore, otherwise we know that NP bar dot product with ON bar equal to 0. Why? Because two vectors perpendicular, then the dot product should be equal to 0. Then the dot product should be equal to 0. Now, NP bar is nothing but OP bar minus ON bar dot product ON bar equal to 0. Now, substitute all values here. R bar minus dn cap into dn cap equal to 0. Just you have to substitute OP bar and ON bar. Now multiply inside R bar dot dn cap minus d into n cap dot n cap equal to 0. D into n cap dot n cap equal to 0. Now R bar dot d square here. D square n cap dot n cap. D n cap minus d square. N cap into n cap is 1 equal to 0. Next, now you have to make the simplification here. D if we are taking common, R bar dot n cap minus d equal to 0. This d send right side, it will become 0. R bar dot n cap equal to d. R bar dot n cap equal to d. This is called this is vector equation, vector form of plane in normal form. Already we discussed in lines also. Vector equation, Cartesian equation also. Here just you have to make the simplification. Again repeating, just multiply inside. What is the common value? D is a common, so D take outside, D send right side. R bar dot n cap. R bar dot n cap equal to D. This is called a vector form of a plane equation in normal form. Next, we discussed about the Cartesian form. Cartesian form is nothing but here. Just you have to substitute the points here. Let P of x comma y comma z be any point in plane. Therefore, OP bar equal to R bar equal to X I cap, Y J cap, Z K cap. And let L comma M comma N are direction cosines of unit vector N cap. Therefore, N cap equal to L I cap plus M J cap N K cap. So these two values substitute here. Therefore, X I cap plus Y J cap plus Z K cap dot L I cap plus M J cap plus N K cap equal to D. If you multiply corresponding elements, Lx plus My plus Nz equal to D. This is Cartesian form of plane in normal form. Cartesian form of a plane equation in normal form. Lx plus My plus Nz equal to D. This is a 5 marks very important question. Once again I am repeating here. Consider a plane first of all in a space. Distance from origin is D. On bar is a normal to the plane. And N cap is the unit vector along the On bar. Therefore, On bar equal to D into N cap. Next, P be any point in a plane with the position vector R bar. Therefore, OP bar equal to R bar. By the diagram, NP bar is perpendicular to On bar. So, dot product is equal to 0. NP bar is nothing but OP bar minus On bar equal to 0. R bar minus D into N cap into D N cap. Just value substitution. These two boxes here substituted. Next, multiply. Common you take D. D and right side it will become 0. R bar dot N cap equal to D is a vector form of a plane equation in normal form. Next, Cartesian form also you have to find. Just Cartesian form is nothing but OP bar. R bar is Xi cap, Yj cap, Zk cap. N cap we have to know here. So let N cap equal to Li plus Mj plus Nk. Substitute there. Dot product means corresponding elements multiplication. Lx plus My plus Nz equal to D. This is a Cartesian equation of a plane in normal form. So pause the video to note it down. Now we start the exercise 11.3. Some more concept is there, but based upon the previous equation and some basic problems is there. First we will complete this one. Exercise 11.3, problem number 1. In each of the following cases, determine the direction cosines, that is nothing but DCs of the normal to the plane, and the distance from the origin. That means D value is asking direction cosines, LMN. Direction cosines, LMN is asking. So given questions here, 4 questions is there. First question we have to take here. Given Z equal to 0. Standard equation first we have to write 0 into X plus, 2, 0 into Y plus 1 into Z, that is nothing but no need to write 1 into Z. plus z equal to 2. First of all, given equation is ax plus by plus z equal to 2. That is a, b, c are the direction ratios. Here L, M, N are the direction cosines. For that purpose, every problem, first of all, you have to convert into normal form. Normal form, how will find here? Here 0, 0, 1 is there now. First of all, 0 square plus 0 square plus 1 square equal to 1 you will get. This equation number 1 you take. Equation 1 divided by here which number getting that number? 0 by 1 into x plus 0 by 1 into y plus 0 by 1 into z equal to 2 by 1. 2 by 1. Therefore, this is in the form of above equation is in the form of Lx plus my plus nz equal to d. Therefore, direction cosines are 0, 0, 1. Why? Because here 0 by 1, 0 by 1. Sorry, here 1 by 1. 0, 0, 1. And distance d equal to 2 by 1 is 2. This is a way of finding the direction cosines and distance from origin. First of all, given equation convert into normal equation. For that purpose, square root of coefficient squares you have to make. Why? Because these are the direction ratios. We have to convert into direction cosines here first. Next, one more problem we'll see. You will get the clarity then. Problem number B here. First of all, given equation x plus y plus z equal to 1. So now, square root of coefficient squares 1 square plus 1 square plus 1 square is root 3. Equation take as a 1. Equation 1 divided by root 3. 1 by root 3 into x plus 1 by root 3 into y plus 1 by root 3 into z equal to 1 by root 3. Above equation in the form of Lx plus my plus nz equal to d. Therefore, direction cosines are, compare L, M, N are the direction cosines. So here 1 by root 3 comma 1 by root 3 comma 1 by root 3 are the direction cosines. Now distance d from the origin is 1 by root 3. That is also 1 by root 3. So this is a way of finding. First of all, given equation convert into normal equation. Normal equation purpose, square root of coefficients that divided by the total equation, both sides. That now direction cosine, compare with Lx plus My plus Nz equal to D. L, M, N are the direction cosines, D is the distance. So I explain here AB problem number C and problem number D. You can see here 2, 3, minus 1. How we will get a square root of 2 square plus 3 square plus 1 square? That is 9 plus 1, total root 14 you will get, divided by root 14. Here 0 is there, nothing is there means 0 x can write. Here you see z is there, 0 x 0 y we wrote. Here also 0 x you can write. These two take as a homework. Pause the video to note it down. Next, exercise 11.2 only. Problem number 2 here. Based upon the previous theorem, that is equation of a plane in normal form. So here you see, find the vector equation of a plane. Just a vector equation. No need to find the Cartesian equation, which is at the distance of 7 units. Solution given distance d equal to 7 first of all. from the origin, and the normal to the vector, that means normal vector they given, normal vector n bar, normal vector is n bar 3 cap plus 5 cap minus 6 cap. This is a normal vector. Unit normal vector we have to find. Unit normal vector to the plane is n cap. N bar is different, n cap is different. N cap is equal to n bar by magnitude of n bar. N bar by magnitude of n bar. That is nothing but here magnitude of n bar equal to square root of 3 square plus 5 square plus minus 6 whole square. That is 9 plus 25 plus 36. So how much you'll get this one? 45. 45 plus 25. 45 plus 25 is root 70. Root 70 you will get. Next, here substitute. Therefore, n cap equal to n bar 3 by square root of 70 I cap plus 5 by square root of 70 j cap minus 6 by square root of 70 k cap. This is the n cap vector. The vector form of a plane equation, plane in normal form is r bar dot n cap equal to d. What is the r bar? R bar as it is you have to write n cap. N cap is 3 by square root of 70 I cap plus 5 by square root of 70 j cap minus 6 by square root of 70 k cap. Distance d equal to 7. So this is the vector equation of a plane. Normal to the vector 3 I cap plus 5 j cap minus 6 k cap with the distance from origin is 7 units. If they are asking Cartesian form also. Cartesian form also asking means what will make here Lmn Lx plus My plus Nz equal to 7. So that is a way of finding the plane equation in vector form. One more example problem is there. Example 13 I displayed there. Find the vector equation of a plane which is at the distance of 6 by root 29 from the origin and normal to the vector 2 I cap minus 3 j cap plus 4 k cap. Also find the Cartesian form. Just you have to simplify the Cartesian form also. So take as a homework. Example 13 take as a homework. Pause the video to note it down. Next, problem number 3 in exercise. Find the Cartesian equation of the following planes. These are the planes in vector form. Is asking Cartesian form. Solution. First problem number A. Given plane r bar dot I cap plus j cap minus k cap equal to 2. We know that just here very simple problem. This is a r bar equal to x I cap y j cap z k cap. This is the arbitrary point. So that's why position vector is that value substitute upside x I cap y j cap plus z k cap. Dot product of I cap plus j cap minus k cap equal to 2. Dot product corresponding elements multiplication. So x y dot 1 is y, z dot minus 1 is minus z equal to 2. This is a Cartesian equation of a plane. Next, remaining problem number B here. Problem number B. R bar substitute x I cap, y j cap, z k cap. Next, here also. coefficient what is there? X into this one plus y into this one, z into this one equal to 15. So this is the way of finding the Cartesian equations of the plane. So this one and problem number B, do as a homework. Pause the video to note it down. Next, problem number 4. In the following cases, find the coordinates of the foot of the perpendicular. Find the foot of the perpendicular drawn from the origin. If one plane is there from origin to plane one perpendicular if you drawn, that perpendicular, foot of the perpendicular. Example, just rough diagram I am drawing here. From origin if you are drawing this one, this foot of the perpendicular is asking. Foot of the perpendicular. That point you have to find here. For that purpose here, simple, this is also by one shortcut method will solve these problems. Solution given problem number A, given equation 2x plus 3y plus 4z equal to 12, constant compulsory, right side you have to mention. Next, same to same, 2 square plus 3 square plus 4 square is 4 plus 9 plus 16, that is root 29. This take as a equation 1. Equation 1 divided by root 29. So what you'll get? 2 by root 29 into x plus 3 by root 29 into y plus 4 by root 29 z equal to 12 by root 29. Both sides you have to divide it with root 29. This above equation is in the form of Lx plus My plus Nz equal to D. So what is L value? Therefore L equal to 2 by root 29, M equal to 3 by root 29, N equal to 4 by root 29, comma D equal to 12 by root 29. Now you have to find the foot of the perpendicular. Foot of the perpendicular direct shortcut form is there. The foot of the perpendicular is LD comma MD comma ND. L into D comma M into D comma N into D. Lengthy method also thereby this is a small problem, so that's why shortcut method will use. LD, MD, ND are direction foot of the perpendicular. Therefore here substitute the values. L is 2 by root 29. L is 2 by root 29 into 12 by root 29, comma 3 by root 29 into 12 by root 29, comma 4 by root 29 into 12 by root 29. 12 twos are 24. 24 divided by root 29 into root 29, 29. 12 threes are 36 by 29, 48 by 29. 48 by 29. Root 29 into root 29 is 29. So now these are the this is the foot of the perpendicular, coordinates of the foot of the perpendicular. This is the way of finding the foot of the perpendicular. This is shortcut form. You have to remember LD, MD, ND are the coordinates of the foot of the perpendicular. And first of all, given equation convert into normal plane equation. That purpose, coefficient square root. This you have to find square root of coefficient squares plus that value divided by total equation, given equation. Lx plus My plus Nz equal to D. Comparison you have to make. Next here, problem number B and C. and D. You can do as a homework that, and example 16 I displayed there. Example 16 also take as a homework that. And here you observe x not there means 0x you have to take. X not there means 0x. And here also x not there. 0x, z also not there. 0z. Here all values is there. And constant value should be compulsory right side. This value, don't take a right side value negative. Why? Because that is distance. Now this question convert as a this way. Only one problem is different way. Compulsory right side positive. So this one send left right side. Minus 5y equal to 8. Next 0x minus 5y plus 0z. So simplification process is same only. That's 3 problems and example 13 take as a homework. Pause the video to note it down. Next, example number 14 and example number 15 based upon the direction, cosines and the distance, based upon first equation related, first plane equation, normal form related questions only. These 2 problems, if we are finishing, next problems will start with the next equation. So that we'll discuss in next session. First of all, we'll see these problems. Example 14. Find the direction cosines of unit vector perpendicular to this vector. Perpendicular to this vector. You have to find the direction cosine. That perpendicular vector directions you have to find. Given r bar dot 6i cap minus 3j cap minus 2k cap equal to 0. Sorry, plus 1 equal to 0. So now, constant should be compulsory right side, that to positive. Positive, here positive is there. If we are saying that side, that will be negative. So that purpose, this value you have to change. R bar dot of minus 6i cap minus taking common plus 3j cap plus 2k cap equal to 1. Here negative you will get, negative common means right side if you are sending that will become positive. Now, same method for all problems. Minus 6 whole square, 3 square plus 2 square. So total value 36 plus 9 plus 4, that is root 49. Root 49 is 7. Therefore, r bar dot of minus 6 by 7 I cap plus 3 by 7 j cap plus 2 by 7 k cap 1 by 7. Otherwise, write down equation 1. 1 divided by 7 on both sides. Now compare with n cap. This is a n cap. R bar dot n cap equal to D. So coefficients, what is there? Direction cosines are minus 6 by 7, 3 by 7, 2 by 7. These are the direction cosines. Next problem number. Every problem first of all convert into normal form. Normal form means square root coefficients, square sign sum divided by total equation. Both sides you have to make division. Compare with that coefficient. What are the coefficients is that are the direction cosines. Next here, find the distance is asking. Problem number 15. Find the distance of the plane from the origin. From origin to this plane distance, that means small d value is asked. Just convert into first of all normal form, Cartesian form. This is a vector form, that is a Cartesian form you have to convert. Given 2x minus 3y plus 4z equal to 6. Minus 6 is the right side if you said positive 6. Right side compulsory positive. Distance always positive, that purpose. Now, square root of coefficient square and sum. Square root of 4 plus 9 plus 16 root 29. Root 29. Equation 1. Equation 1 divided by root 29 on both sides. Now it will become 2 by root 29 into x minus 3 by root 29 into y plus 4 by root 29 into z equal to 6 by root 29. 6 by root 29. This is in the form of Lx plus My plus Nz equal to d. Therefore, distance from the origin d equal to 6 by root 29. 6 by root 29 is the distance from the origin to this plane. So this is the way of finding the distance and direction cosines. Pause the video to note it down.